enclave is done in Code Workbook, which is a UI that lets you import datasets and then write code in R, Python, or SQL. And the reason it's nice and good for data science and research is because you can run things iteratively and sometimes on an ad hoc basis, and then plot graphs and maps, which is why most people use Code Workbooks to run analysis on the data in R. Now, what I started presenting last week is another interface or tool called Code Repositories, which is another product to write code with, but more of on a productionalized basis, meaning that if you have complex data pipelines and you want to run them in an efficient way, and they don't change as much as your analysis where you keep trying things, Code Repositories is usually a good tool for that. And so the way it works is just like you would open up any analysis in the enclave, you would click on Code Repositories. And so you would give it a name. And you would choose which language you want to write your code with. You can have multiple languages within the same repositories, but more often you're going to be using one. The languages supported are Python, SQL, and Java. There are other things that won't be covering much today. You can also create custom Python libraries. So let's say I initialize the repository with Python. And I just wanted to show the mechanics real quick. And after that, I'll just come back to the code repository that I created last week to add more stuff onto it. So this is the code repository that I just created. And as you can see here, it has a collection of scripts and some examples to kind of help you get started. This is mostly Python, but you can add sub-projects. So you can add a SQL project, you can add a Java project. So if I want to add a SQL project, and I just call it MySQL code, this will create a separate folder tree under which you would be able to write your SQL transformations.
Saad, how rigid is that folder structure that's created with the transforms and then the source and then the project name and then the data set subfolder? Like, are those flexible, or is that just the requirements for how it has to be set up for Foundry to do its thing?
You can move a lot of things around. You can have, for example, this script here outside of the datasets folder. Once you start doing that, you just want to pay attention to the paths of not the datasets, but say sometimes you're having scripts here. So like you're having a utility script that you're importing from importing in this script. So this is a transform that takes an input dataset and outputs one or multiple datasets. And then you have your function here, and here we're calling the utils functions. So if you move utils around, it won't be my project that dataset. You'll have to specify a different path or the full path. Does that answer your question?
Yeah, I think it does.
So you can move things around. It's not that rigid, but in terms of like calling different scripts, the things might break if you don't refer to them with the appropriate path. And the way it goes is usually this is your root, that's your folder name. And I think you can even go one level higher if you want to. So here you have, you can create a SQL script by creating new file and selecting the type of your script. And let's just call it MySQL code. And so the structure here is you always want to specify the path of your input data set. And then you want to be saving your output into a path that you can also change or specify, but by default, you'll be saving it under this datasets folder in here. So it's plain SQL code, or in the case of Python, I think I created my SQL script here. So let me move it to under my SQL folder. So that's kind of the structure of the scripts. Let me go back to show some examples from last week. I think I've created a code repository example here. With two projects, a Python project and a SQL project. So for a Python project, usually you have a specification file here in which you any like new imported library gets imported here. You don't need to worry about it as much because say you want to add an existing library, you can do it from the UI. So for example, here, if I just go into the example I just created, if I click on libraries here, I can look for some sort of Python library. So like PyGeos, for example, and then add it from here. This is telling you the repository from which it's pulling the library. And once you do that, if you go back to your source code and you check in the Python project, the meta file, automatically this library has been added here. So the other alternative is you edit your meta.yaml file, but oftentimes you don't have to worry about it. You mostly want to just be using the file, writing in the files under the source project. So going back here, just to kind of remind you of some examples. So if we look at a typical Python transform, the way you specify your inputs is with this transform df decorator, which is basically an interface that lets you read and read datasets that are saved in the enclave and write into the enclave. And the way it works is always you add this decorator syntax at transform df, and then you're able to use these input and output functions to read in your datasets. I think there is there's some documentation here. If you click on the docs and you select Python, you have anything that is in the transforms API. So for example, inputs, this is how you specify the inputs by either putting the absolute path of the dataset or what we call the resource ID, which is the URL link, part of the URL link of the dataset. So there are some advanced features. For example, you can set up what we call incremental transformations. And what I mean by that is you can have a transformation that adds rows to a specific data set every time you run it, if instead of like rerunning the whole transformation. So here in this script, I'm just pulling this input first SQL example, which I've created within the same repository. And I can go back here and say, and so this has just the concept set name, concept ID, and concept name. And the way it was created was with this repository itself. And this will take me back to the query that created it. So last week I created this SQL transformation by starting from the concept set members table and then selecting just these 4 columns: concept set name, ID, concept name, and code set ID, and filtering to the most recent version. That generated this first SQL example data set that I have here. And I'm reusing this within the same repository in this Python transformation. So here I'm reusing this first SQL example, and I'm just doing some basic transformations to it. So in a Python transform, you have your main function here, which takes your data frame input, and then you can start applying transformations to it here. So this is PySpark syntax. I'm selecting these 2 columns, and then I'm doing some renaming of a specific column. And the renaming was created using this utils script that I created here with my function rename column that takes in a data frame, a column name, and a new name, and uses PySpark syntax to rename the column. So from here, I think I ran this transformation last week. I think I didn't run it, so let me just build it real quick. And once it's built, I just want to show an aggregation example and then a custom library example. Any questions so far? I know I'm jumping around and maybe repeating some of the concepts I mentioned last week.
I had a question that I thought of when you were just showing that SQL transform again. If you needed to run multiple SQL statements in a particular order, can you put them both in the same .SQL file in the order that you want them to run, or should you create multiple SQL files, and is there a way to specify the order of that?
No, you can run a giant SQL here, just like you would do in any type of SQL query. The only constraint, if you will, is that your end statement is right into a specific output. So you can create intermediary tables and just like put the SQL statements into brackets. And so one SQL statement into bracket generates a table, which you will rename as an alias, and you can reuse that alias into the following step of your SQL statements. So you can have everything in one script. You don't have to kind of break it down into multiple scripts. I'm trying to think if there are examples of that. I've seen them in the enclave of people running giant SQL statements, especially on the DINH side.
But it should be one SQL statement. It's not like you would have a create table and then a whole separate, blank.
No, yeah, sorry. Yeah, one SQL statement, yeah. Is this, just double checking that this is actually running.
Right, we're back. Thank you very much. Again, to mine.
Sorry, what was the question? Okay, so this is when you run a script, it just runs some basic checks. You can look at the details of the checks here. When you have errors, you can look at the logs of the errors here. And now that the checks are ran, it's moving to the built-in dataset step. So you have this build tab that you can monitor. And if you click on view build, you'll see details of your build, including some Spark details. If you have a giant build, you can look at the infrastructure. I think what's useful is, well, the query hasn't really started yet, so we don't have enough information. about it. But it's useful when you have build errors to kind of go to this build view page and look at the details. Otherwise, you just wait for it to finish. And when it's done, you'll have a preview of your output here. So this is mostly just returning true columns, and the data set will be, if you want to open the data set, if you hover over the output, you'll be able to open it on the same or different tab and look at the results. And as you can see here, it was updated via this code repository, so you can go back here and make further updates. And yeah, that's so another thing we can do here is I'm just going to show you an example of an aggregation, but maybe I'll do it using a pull request, so that I re-show the mechanism of pull requests. Let me just delete my changes. I'm not sure what the commit. The commit was just to change this to from a path to an actual hyperlink. So let me commit this change. And again, I'm going to go back in the settings and lock my master branch and protect it. So let's save these configurations. So right now it's requiring an approval from this user for the pull request to be able to merge. So now I'm going to create, since I can't edit my master branch, I'm going to create a new branch, and let's just call it my aggregation branch.
So did you need to check the checkbox next to that in the build settings?
Which checkbox?
To the left of the require approval.
Yes, yes, I forgot to do that. Thank you, Sean. That's a good point. So going back here, maybe something I want to add is, let's call this step aggregation of data frame. And what I want to do is, let's create a data frame called dfag. And it will be a group by of the previous data set, output data sets dot group by. So this is PySpark syntax. And maybe I want to group by, this is a dummy example, but let me group by concept name, and I'm going to show the count of by concept name. So the number of records for each concept name. So the way it goes is you do that group by concept name and then that ag. And then in order to aggregate, I need to use the PySpark SQL functions library. So let me add it here from PySpark.SQL import functions and rename it as F. And so I can do something like F that counts of my concept names or my IDs. And then just rename the count column to something like number of records. So let's try something as simple as that, and we're going to return the aggregated data frame. It's telling me that there are uncommitted changes, which are basically my changes. So I'm going to merge them. And now I can preview my code and see if that works. And if it works, I'll run a build to save the results in my Python output dataset.
John?
Yes.
When you name your branch and put SL/, characters, is that just your own naming convention, or are you actually creating some kind of path name with a slash to separate parts of the path name?
Yeah, you can name your branch anything you want. As a habit, I tend to put initials and then what the branch is supposed to do, just as a good practice, and for people to be able to review, but you can name your branch anything you want.
Okay, so it has nothing to do with the, I mean, it's not like you're creating a directory structure, you just have a name.
No, yeah. Yeah, so I can create something like that I want to call maybe dummy branch, and I can branch either from the existing branch or from the master branch. So like I can create a tree of branches here, but it has nothing to do with the name.
Okay,
So this is my dummy branch. So let me switch back to my aggregation, and I think I can't recall if I ran the preview, but let me actually rerun the preview quickly. Excuse me. So as you can see, this ran the aggregation, concept name, and number of records. So let me build this. And once I build it and it's done, I'll be able to merge my branch to master. You don't have to build your data set in order to be able to merge your code to master, but it's good practice. And sometimes in your pull request, the code assist will complain and give you a warning that the data sets in your current branch haven't built. And so you may want to check that it builds properly and returns the correct results before merging into the master branch. So I prefer just like running the whole code in the master and then in my local branch and then merging back to master. I think it shouldn't take a long time, I believe so. Maybe just a minute.
If you write
Yes.
a data set from a branch, is that a branched data set as well, like in the same way it does it from a code workbook?
Mm-hmm. Yes, so you'll be able to see it here once it finishes. So this is the master, and I think it was run. This was run 7 minutes ago. And if I switch to my SL aggregations, right now it's still running, but when it finishes, you'll have the new aggregated data, and the two versions will be different. Even if you merge your code to masters, you'll have to rebuild the data set in master in order for the data to be reflective of your latest code. So let's just give it a minute. So right now it's done. I can open the data set from here by clicking on view data set. So it's opened it in master, but since I'm on my branch, I can check the results on my branch SL aggregation. And as you can see here, the results are different. I have the results corresponding to my code in this branch, which adds an additional aggregation. So you can see the number of records per concept name. And now if you're happy with your code and you're happy with your changes, you can propose the changes to master. It generates like a title for your pull request, which is the name of your branch, but you can give it a more meaningful title. So aggregation of concepts, and you can give a more detailed description here. Something like count of concept names. This is a dummy description, obviously, but better your description, the easier it will be for people to review your changes. And this is kind of like the diff between the previous file and your new script. So in your new script, you're just having an additional line of code, which does the aggregation. These are some hidden files that just like record any additional data sets that you might have created. So you don't have to worry about this. This is mostly what you want to worry about. And so let's create the pull request.
Oh, Saad,
Yes.
the same way it is comparing the two code sets side by side. Does it
Yes.
also compare? Can we also compare the data sets side by side? The output,
Yeah.
the data output, you can. Okay.
Yes, and there are a few ways to do that. One way I like to do is you can do it on this UI, but you can also do it on the dataset UI. So there is a compare tab here.
Oh, okay. Got it.
And you can actually, so this is comparing your branch, and in master, this is giving you more information. So these are completely different data sets. In this one, you have number of records as a column. This one has ID. This is like, this is the diff, but you can also include the matches. So concept name is the same, but then here you have a column that doesn't exist here. And if there are diffs in the data, you'll be able to see them here. Obviously, the diffs in the data are more difficult because your data sets can be gigantic. And so this is just a preview of the diffs of the data. And then here you have the difference, the diffs for your code. I think some of the most useful things for me are the column diffs. So they can be diffs in the column names, but also the types, the number of nulls, min, max statistics. These kind of help you figure out if your data changed or not. Does that answer your question?
Yes, yes, definitely. Oh, this is so useful. So it's, as you pointed out, the code is probably crisp and small and small, whereas when it comes to the data set, it could be so massive that it kind of, I think it probably just gives you a preview of what has changed or what is different.
Yeah, yeah, a preview, and then you can do further. Like if there are some stats that are not here, you want to define your custom statistic to see if it changed between your new data set and the previous data set. You can also always jump into Contour. And then in Contour, you'll be able to, and even include your book, actually, you'll be able to define your metric that you want to compare between the two branches. And the way to do that is you can always select your branch here and then create another path with the same data set, but the master branch. And then for both paths, you can compare your metric by joining the paths. Does that help? Does that make sense?
Yeah, definitely. Definitely.
So then you can always have conversations on your pull requests or this is sort of like a pipeline review. It's more relevant when you have many data sets. It's like a data lineage view. Here, I didn't create any kind of like new data sets, so it will not be that relevant. So the most relevant thing in my case is the file, the code change. So once you're happy with your change, you can hit approve. And then I think once it's approved, you should be able to merge. Required approvals are missing. Additional approvers. Sometimes it's weird when I create the data sets myself and I approve it myself with these kind of constraints. So I'm just gonna double check what I did here. So So if I go back to my pull request tab, for some reason, I'm still not able to merge. I think I just need to remove myself as an approver. Might not like it that I'm trying to approve it myself. But this is more relevant when another person is approving your code or you're approving the code of another person. So I'll go back here and merge my changes. And I can give a commit message here. So something like aggregated the data sets. And that's what you'll see on the diffs. So once you merge, that means right now that your master branch is exactly the same as your SL aggregation branch. So you can choose to delete your local branch if you don't need to work on it anymore, or you can choose to keep it. In my case, I'll just delete it. So if I go back to code, it will automatically open my master branch with the new code. And if you look at file changes, you'll be able to see the diffs with the commit message. So this is the last commit message, aggregated the data set. And you can see that I've added this line of code here. But now the important thing is that the code is updated on master, but the data set is still pointing, like I still need to rerun my code in the master branch in order for my changes to be reflected on the data. As you can see here, it's still, if I go back to my master branch, this is still pointing to the previous version of the dataset, which ran 16 minutes ago. So if I want my changes to be effective, I need to rebuild my dataset either from here or from the dataset UI. So this will start a new build that I can monitor here, and it should take about a minute for my dataset to update. Before I jump to custom Python libraries, I just want to make sure I mentioned everything here on the UI. So like I said last week, this is an explorer where you can find the data sets you're looking for. So if I do something like condition occurrence, well, I'm looking for collection names, so I'll just do a search everywhere. Actually, easier to find on the data catalog. So say I want to import device exposure. I have a preview of the data set here in my code repository, and I can copy the location from here and use it in my code. Any type of issues of like, especially code assist issues or issues in your or warnings will be displayed in this tab. You can see now my data set updated. You have a debugger here, which I mentioned a little bit last week. You can put breakpoints and then run a preview and then step in to your code and display intermediary variables in here. We mentioned the file changes. I mentioned the docs, and I mentioned the standalone, the ad hoc queries, SQL queries. We've talked about branches, the fact that you be able to like monitor your branches here, maybe delete them if you don't need them anymore. This tab is the one that lists your pull requests, open or closed, so you can review them from here. And then the settings are just more advanced settings about how you manage your branches and change management. You can jump to the data lineage app and explore it from here if you click on explore data lineage. Right now, my pipeline is very small, so I only have one input data set. I'm starting from concept set member. So if I if I filter by repository, I have my EUG code repository, which created these two data sets, and I can look at the code here. So if I select the data set, you will be able to see that this one was created using this SQL statement, and this one was created using this Python code. And you can jump into the code repository from here, or look at a preview of the data sets here. You can also switch between branches in here. So if I look for my aggregation branch, I can find it in here. And so what this will show me is the state of the data set as well as the state of the code in this branch. Right now they're in sync, and it's probably going to tell me that I've already deleted my branch. But you can look at the details in this app as well.
And also the multiple sources, data sources, you can get a view of what are all the different hospitals or different sources I have aggregated data from. That also can be visualized, am I right here? If this is only you have one source, but you could have connected multiple sources.
Yeah, I mean, any data sets in the enclave that you have access to, you can view it from here. And that includes, sorry, go ahead.
And then again, using you can merge, aggregate them from the pick and choose the data columns you want from multiple sources, and then aggregate them, and then you can visualize what are all the sources those data came from in this place.
Yeah, I think that's something that people commonly do is they aggregate things by, say, data partner ID or by common data model, and visualize the results by that level of aggregation. So you do have, for example, site IDs or data partner IDs in your OMAP data sets that are in the data catalog. So you can definitely do that aggregation. I'm not sure if that's what you mean when you said sources, because sources here are basically data partner IDs, or if you will, common data models.
Yeah, that's exactly what I was thinking, because you kind of did the demo with one source, am I right? But
yes,
you could have easily merged data from multiple sources.
Absolutely, yeah. This is a dummy example, and I use only one data set as an input, but I could easily add, let's say I want to add condition occurrence here. So let me just unprotect this branch to go quickly. So the way I would do that is, let's say I want to add, oops, I want a little bit fast. Another source, which is the condition table. And let's find it actually from the data catalog. I mean, in your case, it'll be the de-identified or LDS data collection. But obviously in this call, we're just using notional data. So I can pick condition occurrence. So that has, I believe it has data provide. It doesn't have data partner ID. I guess maybe it's person table that has data partner ID.
Try the Cynthia when you're in the SynPath, which is incredible.
Oh, whoops. Okay, thanks. Cynthia. So if I pick, say, person, it should have a data partner ID column. Yeah. So I can do something like I add in this table, which is another source. Let's just call it person. And the way you read the person table is by saying input and then providing the path that I just copied from here. And now that I have person, I can read it. It will be an input of my function. And so now I can play with person as well. So I can do something like person data frame equals person dot select, and then we just select the data partner IDs with something else. But I think you get the idea that you can bring in multiple sources from your OMAP data sets and then aggregate them here and then combine them, join them, and then produce results. Does that answer your question?
Yes,
Prabhu?
yeah, this is awesome. Thank you so much, sir.
Okay, great. So I think next example, I'll go through it quickly.
So
Let's
this
create, yeah,
a
go ahead.
basic question.
Sure.
What if I'm more comfortable with pandas and my data frame is small? Is there like an obvious convert to pandas?
Yeah. So you would do import pandas, maybe as PD. And then you would do something like person, let's just call it person pandas equals. So by default, there's Spark data frames, but if you do person that true pandas, this will become a pandas data frame. And then you can use PD that any other, any pandas utilities. But that's a good question. I think a lot of people are more comfortable with pandas than PySpark. So you can definitely do that. If your data set is small enough, I encourage you to do that and use it. And then you can return, I think, hold on, actually, let me check the docs. I think there is another way. So one way to do it is this, true pandas. But I think there's also a transform pandas decorator, which reads the data sets directly as pandas data frame. So the way you want to do it is you do from transform dot API import, and instead of transforms df, you would be transform pandas. And so here, the decorator name, and you have an example here. It would be at transform pandas instead of transform dfs, and these will automatically be read as pandas data frame and returned as pandas data frame. And this is, I think, an example here that you have. Does that make sense?
Yeah, thank you.
And then you can go back and forth. This is between pandas and Spark. And this is, I think, an example in how you do it. You just do that create data frame and your pandas data frame to return a Spark data frame. So you can do conversions within the same script. Any other questions? So I think what I wanted to show now briefly is the custom Python library component. So by default, when you create a repository, we call it a transforms repository, whether it's a Python or a SQL. And what it means is that it usually takes input data sets and then returns output data sets. But what if you want to create just like some sort of like utility library, maybe a machine learning library? The way you do that is you want to initialize a Python library here. And let's just give it a name, something like let's just call it EUG custom Python library. And when you create initialize, so right now the structure is slightly different. You have, sorry, these are not relevant files, they're just configuration files, but you have a README you don't have a data set, an example.py, which tells you here's how you specify your input and output. You have a README that gives you the instructions on how to publish your, if you were to create a Python library, how to publish it so that you can reuse the library in other code repositories or in other code workbooks. And other users and of the enclave can also use and benefit from your library. And so the way to do that is there's some few edits to be able to publish your library, but first let's just create let's just maybe create some utility functions, and they're inside of my project. Let me call this because this will be my package name. So let's just call it my example package. And within it, I'm going to create a new file. And let's just call it something like utility functions.py. So let's make it a Python file. Sorry, I think I meant to, let me delete this. Let's recreate again. Instead of a Python transformations, I meant to create just a regular Python file. And so this will be an empty file. And let me just define maybe a couple functions. So let's say I want to define, and these are just dummy examples, obviously, but you can define your functions here. So let's something like drop columns from data frame, where you input a data frame and a column to drop. And it will return the data frame with the dropped column. Let me maybe do another one in which you're just selecting a specific column. From a data frame. So that's my second function, and this will return my data frame that selects and the column to select. So let's say I created my my package here with like all its functions, etc. Let me commit my changes. And let's actually, we're going to build these changes. This will not generate a data set. It will mostly run some checks and tell us if there are any issues. And so what it's saying here is that this is just by default, this is the package name is going to be the folder name, and the library name is going to be the repository name, but you can change it. There are some hidden configuration files here from which you can change the package name. So if you click on this file, greater.properties, this is by default your package name. So when you go to Code Workbook and you try to load the package from the environment, this is what it will be called. But then again, you can edit the file here and change the name of your package. The other thing it's telling you is that if you want to publish this library to what we call a shared channel, and what this means is that anyone can access the library, you need to edit this file, build.gradle, and add the channel name here. So add basically this line of code. So this is mostly the only thing that you need to do to make your library available to other people. I mean, otherwise, you can still access the library within your code repository or other code repositories. But if you want to publish it to, say, Code Workbook, you'd want to do this additional step. which is basically go into this build.gradle and then add in the publish channel name here. So let's commit the changes.
So
And
did you want the markdown backticks in there too?
I'm sorry, did I mess up something? Yeah. I think so second. I need to remove this. Keep copying it with the markdown. So let's recommit this. And so before you check, so when you look, let's wait for this check to finish. For some reason, this one failed. But maybe it was because I was editing the file at the same time. So let's just wait for this to finish. This is just a styling. And at the same time, let me try to open another code repository to show you how to reuse the existing library that I just created. But again, I'm realizing I'm almost at time. So briefly, once your library publishes, what you want to do is make sure it has at least a tag, because that's all the branch section, because that's the version of your library. So if you want to create a new version, you can create a new tag 1.0.0 and have it tied to a specific branch. Once you do that, it will take a few minutes to run your checks. And when it's done, you'll be able to refer to your library from existing code repositories. So if I open this code repository, maybe let me create another one real quick. Any questions so far? And I'm sorry if this is running a little bit over time.
I think we can go a little bit long today, given that it's like there's maybe just a few minutes left.
Yeah.
Folks have to sign off. We'll be sure to record through the end so that you can zoom to it on YouTube.
So I'm going to initialize a new repository. It looks like the check succeeded this time, which is great. So if you go to your branches and you check your tag and you look at the commits, that you have a succeeded check, which means that your library is published properly. And so I believe now if you look for libraries and then you look for EUG, there you go, custom library, you'll be able to find it here and add the library to your code repository. And so when you create say a new, let's just do it here. In examples, you can do so you can do things like from, and the package name is my example package. So you can do from my example package import, and then you can have multiple scripts, and each script is like a set of functions. So I'm going to import utility functions. Let's just recall it u. And so you can do things now like For example, if my input is your data frame, you can do u dot data. Whoops, sorry. U dot your function name. So here, drop column from data frame, and then your data frame name and whatever column name you want to drop, and basically use your package that you've deployed using this Python custom Python package code repository. You can use it in this code workbook by calling it from here in Python. And similarly, you can also use it in code workbook. So if you open the code workbook, you can also customize the environment, maybe choose a light profile. And if you look here, hopefully it should have published by now, but here is the library that I just created. And so I can do update Spark environment. And once this updates, I can refer to the library from the console or from any other transformation the same way, meaning from example package, import whatever set of functions I have and play with it in here. And yeah, for further more informations about how these things work, I'm just going to refer you to the appropriate platform documentation. So again, anything documentation related can be found in this training materials section. There's a platform documentation section here, and the section has a code repository page. And so specifically here, we've covered Python transformations, and there are a lot of how-to things, such as how to deploy custom Python library. Just Python package, maybe. Yeah, sorry, I can't recall which page exactly details the steps to deploy a Python package library, but it is in here somewhere. So I'll find it and send it to you guys as a follow-up. Code repository is much more powerful. It has a lot of other features that you guys can explore, more than code workbook. It's maybe less adapted to data science type of workflows, because you have that in code workbook, you have things like visualizing, you have the use of R, you can visualize plots, and this is something that is less supported in here, but there's a lot more support in terms of using different APIs and in terms of change management that code repository supports. Any questions? Reactions? Concerns?
I think it's pretty neat. I know especially like the ML group was interested in doing stuff a little bit more along the lines of a Python package. I'm curious about how things might go with if someone does that and then they wanted to publish it in the knowledge portal, because it seems like that's built largely around code templates. So maybe someone would publish a package and then have an example workbook that uses the template. Or would it make sense to put the repository itself directly in the knowledge store with documentation?
We could put the repository in the knowledge store with the documentation. But I'm thinking the most useful is mostly just a report that documents how to use the library, because having the code repository of the library in itself may or may not be useful depending on the documentation. You may want to look at the source code, or maybe the creator doesn't want to share the source code and they just want to share the API. So it depends on what you want to share. I would say, however, if it's easier to track attribution if we create maybe a code workbook template that uses that library, that loads basically that library, so that it's easier to track where your custom library is being used in other projects.
Yeah.
Any questions, Prabhu, Hannah, Richard? Sorry
No,
for
no,
putting you on the spot.
this was great. I mean, it's a lot to learn, but it's amazing. It's so powerful.
Yeah, I mean, just let us know. There are always mechanisms to seek support if you're stuck, or if you have, say, a use case in mind and you're trying to achieve it and you're not sure how, just feel free to hit us up via issues or Slack or office hours, and we can help you at least to get started.
Sure. I mean, as I said, I am currently working with all the 5 UC data set, and we have almost done the analysis with regards to endocrine disorders and COVID. And the goal is, once we are kind of confident that we found something significant, to replicate that in the N3C enclave.
Okay, yeah, whenever you're ready to replicate it, just let us know.
Thank you.
And we can guide you through that.
Thank you, Saad and Sean, S&S.
All right, thank you everyone, and sorry that I went over time. Not sure, Sean, if you wanted to wrap it up.
Probably a good time to wrap it up. Richard, do you have a question?
No, just want to say thank you. This is very useful.
Yes, that's what I was going to say.
No problem. Thank you guys for joining.